This is a video that deals with exponential growth and decay, and will answer the essential question: how do you solve differential equations using separation of variables? And I'm going to show one example of the separation of variables technique to solving differential equations. So solve this differential equation. dy over dx equals the quantity y plus 1 over x plus 1 with a given initial condition y equals 3 when x equals 3. So the first thing we do is we separate the variables so that the y's are on one side. So when we divide by y plus 1 on the left, we end up with 1 over y plus 1 dy. And multiply both sides by dx, we end up with 1 over x plus 1 dx. So the variables are separated. The left side are just the y's, the right side are just the x's. That allows us to integrate both sides. So we take the integral of both sides. And when we integrate, you'll notice that the two sides of the equation are the exact same, the only difference being x and y. So let's integrate the left side. We'll do a u substitution with u being y plus 1. And follow this through, keeping in mind that, actually we want dy because we don't have x. Keeping in mind that what we do here on the left side is going to be the exact same thing that we do on the right side, and we're not going to do it twice. So we'll just do it once and then apply it to both sides. So du equals dy for our u substitution. And so now our integral is actually the integral of 1 over u du. And that's a simple enough antiderivative to come up with. That is equal to the natural log of the absolute value of u plus c is the general solution. So if we apply that u substitution both to the y plus 1 on the left and to the x plus 1 on the right, if we apply that as if we did it on both sides, then this solution ends up being the natural log of the absolute value of y plus 1 is equal to the natural log of the absolute value of x plus 1, that quantity, plus c. And we only need to add the plus c on one side of this. So that's the general solution right now without solving for y. We're going to take our initial values, this y equals 3 when x equals 3. We're going to use those initial values to solve for c. So let's plug those in. So the natural log of the absolute value of 3 plus 1 equals the natural log of the absolute value of 3 plus 1 plus c. You might see where this is going. The natural log of 4 equals the natural log of 4 plus c. So in our case, c equals 0 for this example. So c is 0. Right, that gives us now the particular solution, the natural log of the absolute value of y plus 1. Try that again. Y plus 1 is equal to the natural log of the absolute value of x plus 1. And the c's value is 0, so plus 0 or leave it off. Now to solve, we exponentiate both sides, raising both sides to the e power, as exponents to the base e, exponentiate, and since both sides of the equation are natural log expressions, raising them as exponents to a base of e will cancel out both natural logs, and we have the absolute value of y plus 1 is equal to the absolute value of x plus 1. Now given this situation, we need to undo the absolute values on the left side, the y plus 1 side, and the way that we do that, again, is we create the positive case and the negative case. This is what we do when we undo absolute values. So the positive case being where y plus 1 is equal to the right side of the equation as it is, the negative case being where y plus 1 is equal to the opposite, or the negative of the absolute value of x plus 1. And then solving for y, we end up with two solutions. Y is equal to the absolute value of x plus 1 minus 1, and y is equal to the absolute value of x, the opposite negative absolute value of x plus 1, sorry about that, minus 1. So one of these two is potentially the solution. Now we have to keep in mind our initial conditions, and that was that y is equal to 3 when x equals 3. So if we were to plug 3 in here for x, plug 3 in here for x, one of those solutions, the positive or the negative case, is going to get us a y value of 3. And knowing that the y is positive, it's going to be this one. This is going to be our one solution. So the solution to our original differential equation is y equals the absolute value of x plus 1 minus 1. That's the one solution, not this one. That doesn't include our initial condition. And as far as the input into this equation goes, the domain, the input for x, the domain is all real numbers. All real numbers for x can be input into this equation. That's the solution to the differential equation.